Howdy, 7th grade. Today we're going to be talking about some special cases of right triangles. I wrote similar there. I should actually say special. Sorry about that. So we're doing special right triangles today. And there's two different special right triangles. We'll talk a little bit about what makes them special. But what makes them special is that they're ones that come up a lot, and we know a lot of things about these two kinds. So the two special right triangles we're going to be talking about are both right triangles. They both have a right angle here. One is going to be the isosceles right triangle, which means that both these sides are going to be the same size, and both these angles, if they're 45 degrees, of course, they're also the same. So we call this a 45-45-90 triangle because the angle measures are 45-45-90. The other special one we're going to have is going to be a little bit different, and it's going to have a 60-degree angle and a 30-degree angle. So we call this a 30-60-90 triangle. And again, we know a lot about both of these triangles, which is going to make them very, very useful for us. And it's a lot like the similar triangles we talked about yesterday. So instead of similar triangles in general, we just have these right triangles kind of as templates, and if we find triangles similar to these, then we can use things we know about these to solve problems with them. Which I recognize sounds kind of confusing right now, but I'll show you guys a couple examples. So for the 45-45-90, we will remember that that is the one where this is 90 degrees, 45, and 45, which I hope is fairly easy to remember because it's called 45-45-90. In any case, we know the ratios of the sides. So all the triangles that look like this are going to have ratios of 1, 1, and square root of 2. Anytime you see a right angle and two 45-degree angles, the ratios here are going to be 1, 1, and square root of 2. And that's just the end of it. So anytime you see a triangle similar to this, you can set up a ratio like we were doing with the similar triangles to find the other sides. So we're going to do a quick example. And my example here is going to be that I have a triangle that is a 45-45-90 triangle. And I know that this bottom side here has the length of 15. So if I want to find, let me not do a question mark, let me use actual variables so we can label these better. X and Y, if I want to find X, well, I know that the ratio from here to here is going to be 1 to 1. That has to be equal to 15 to X. So 15 to X has to be the same as 1 to 1, and that's because the ratios of the sides here are going to be the same. So to get from 1 to 15, I multiply by 15. 1 to X, I'll also multiply by 15, which tells me that X must equal 1 times 15 is 15, and just like that, I'm done. If I want to find Y, we do the same thing with our base triangle. This can be 1 and square root of 2. So know that 1 to the square root of 2 is going to be the same as 15 to Y. So I have to multiply 1 by 15 to get 15. So square root of 2 times 15 is going to be Y. I have Y equals square root of 2 times 15. I know we haven't done much with square roots yet, so I would just leave it as square root of 2 times 15. That is, in fact, as simple as it gets. You cannot simplify that anymore. So if you have a square root times something, just leave it there. You're good to go. Next, we're going to try our 30-60-90 triangle. I'll tell you the ratios here. That is not what a 30-60-90 triangle looks like. Here we go. If I actually get this going straight down, that'll look just about right. So we have a 30-degree angle, 60-degree angle, and a 90-degree angle. And we know for our 30-60-90 triangle that the ratios are 1 down here. The shortest side is 1. The longest side is 2. And this middle side is going to be the square root of 3. So it's 1 to square root of 3, where the shortest is 1 and the longest is 2. The middle square root of 3, that's going to be our ratios. And these are ratios we're going to use all the time just to make our lives a little bit easier. So if I have a problem where I have a 30, 60, 90 triangle, this is my 60 side, 30, and 90, and let's say this side right here has a length of 16. I would know that x and y, to find x, I would be able to say that my ratio of this side here to this side here has to be the same as 16 to x. So 2 to the square root of 3 has to be the same as 16 to x. So to get from 2 to 16, I would multiply by 8. From root 3 to x, I would also therefore have to multiply by 8. I would end up with x equals root 3 times 8. Just like that, I'm done. We'll do the same thing for y, finding y. To get from 16 to the y down here, 16 to y, that would be the same ratio as my 2 to 1. It's 2 to 1. So to get from 2 to 16, I would multiply by 8, give me 16. So to get from 1 to y, I would also have to multiply by 8. And I would get y equals 8. Just like that, I'm finished, good to go. So that's how most of these problems are going to look. An important thing is that we remember our ratios for the 45, 45, 90, and for the 30, 60, 90 triangle, and this is going to be the same ratios no matter how I orient this thing, is that the longest side on this one is always going to be the square root of 2, both the others are 1, and over here, if I orient this strangely as well, I'll get my longest side is 2, my shortest side is 1, and my middle side here is going to be the square root of 3. I'm going to label this as 60 and 30, and just like that, we're good to go. So please make sure you do the lesson practice, and I'll see y'all in class tomorrow. Have a great day.